Good morning, class. We are looking at Chapter 7, Analytic Trigonometry. Just for the sake of argument, 7.3 trigonometric equations versus OpenStax text. If you go to OpenStax, it's 7.1 trigonometric equation. So it depends on the text, but we are more importantly interested in the topic of trigonometric equations. What are we going to cover? Solve equations involving a single trigonometric function. Solve trigonometric equations using a calculator. Solve trigonometric equations quadratic in form. In other words, remember the quadratic formula. Solve trigonometric equations using fundamental identities. Solve trigonometric equations using a graphing utility. And so again, refreshing everyone's memory about what we have seen, the unit circle and the fact that every point with coordinates x, y are represented as cosine for x, sine for y. Here's the identities that you've seen. And the fact that all trigonometric functions are periodic functions with the period of 2 pi, tangent and cotangent with the period of pi. They are all odd functions with the exception of cosine and therefore secant. Remember, an even function, that means if you change the x to minus x, you get the same function. Odd means cosine of, for example, minus x is cosine of x. This is odd, but sine of minus x is minus sine x. That's an odd function. This is even. Cosine is. Fundamental identities, Pythagorean identities, quotient identities, reciprocal identities, we've seen it. As far as graphing, we cut it into 4 equal arcs with 5 key points for the case of a sine and cosine, and we graph it. You remember that? Okay. Andrew, you remember the amplitude and the period. Period is 2 pi on a regular basis. But if you happen to have a sine omega x, the number in front of x, you divide the 2 pi by it. So, and of course, none of the trigonometric functions are one-to-one. Therefore, you restrict the domain to make it one-to-one, and it creates an inverse trig functions. Therefore, you have to remember the restriction. We put the restriction, for example, on sine from minus pi over 2 to pi over 2. The range, of course, you want to cover all the range, which is negative 1 to 1, and it gets reversed in the case of an inverse function. So you want to be careful with that. And by the way, we use the same thing for tangent and cosecant, of course, with extra restrictions. And cosine, we go from 0 to pi, remember that. And with cosine, secant follows and cotangent follows, okay. And as I mentioned, tangent, we basically use the same as sine. Of course, the difference is in the case of a sine, we have the equality at negative pi over 2 and pi over 2. But over here, we don't, because those are vertical asymptotes. X equals minus pi over 2 and x equals positive pi over 2. So again, that's a synopsis of what you need to know. Let's move on. We are starting with checking the solution. If you recall, the very first time we did equations in algebra, we would be given a solution to check. So we want to determine whether theta equals pi over 4 is a solution of this equation. 2 sine theta plus square root of 2 equals 0, which means just plug in and observe. And then we want to look at another one, theta equals 5 pi over 4. So let's start with theta equals pi over 4. Plug in. So 2 sine of theta is sine of pi over 4 plus square root of 2. And is it equal to 0? That's what we are looking at. Well, this is a common arc, square root of 2 over 2. And now we have square root of 2 plus square root of 2, which is 2 square root of 2. Is it equal to 0? No, Therefore, pi over 4 is not a solution. Let's try with 5 pi over 4. Again, 5 pi over 4 is a common arc. And again, I want to remind you that when it comes to that, you should recognize pi over 4 is the reference arc, which means the same number works for sine. All you have to do if it's positive or negative. So again, the concept of a reference arc. What is the reference arc for 5 pi over 4 is pi over 4. Therefore, sine of 5 pi over 4 and sine of pi over 4 have the same value, but the sign depends on the quadrant. Okay. Now, 5 pi over 4 is larger than pi, puts you in the third quadrant. In third quadrant, sine is negative. So you use the same number, but negative. And that's the key. So you have minus square root of 2, plus square root of 2, square root of 2. The answer is 0. Therefore, 5 pi over 4, it is a solution. All right. 2 sine x minus 1 equal to 0. You can move the 1 and divide by 2. Sine x equals positive 1/2. Well, if we are interested in the interval of 0 to 2 pi, as you know, x is pi over 6. Which is the first quadrant. Sine is positive in the second quadrant as well. So pi minus pi over 6 or 5 pi over 6. First, let me change a couple of things. Maybe I should change this to theta. Now, when you have this one, and you know sine is positive in quadrant 1 as well as quadrant 2, to find the answer for quadrant 2, you can say pi minus pi over 6 to get this answer. I'm assuming everybody remembers that and the concept of a reference arc. For part B, we take this to the other side, becomes positive square root of 3, and now we divide by 2. As for example, this one, we took it to the other side and divided by 2. As far as the general solution, by the way, in this example, I wanted to do both. As far as general solution, in other words, all coterminal angles, that's the terminology. All you have to do, add 2n pi or 2k pi. In some texts we may use, or even in this case, sometimes we use 2n pi. It's the same thing, class. N or k are integers. To remind you what is the set of integers, okay, maybe I put it up here. So 1, 2, 3 to infinity. On the right side, 0, -1, -2. This is the set of integers. Remember, class, natural numbers would start from 1 and to go to infinity, 1 to 3. Whole numbers will have 0 also. Integers go on the negative side also. It's called I or integers. So 2n pi, 2k pi, that means the same thing. Now, let's go to, let's do part B. To do part B, we're going to move a negative square root of 3 and becomes positive square root of 3 on the other side. We're going to divide by 2 and cosine becomes square root of 3 over 2. Common arc. Same thing, pi over 6. Now, how do we get the second one, which is 11 pi over 6? I want to show you that one. So when you see that, when you know, this you should know, then cosine is positive also in the fourth quadrant. And in the fourth quadrant, you're going to say 2 pi minus the reference arc, which is 2 pi minus pi over 6 to get 11 pi over 6. This is how you find all your answers from 0 to 2 pi. But what if we wanted, in general, all solutions, not necessarily from 0 to 2 pi? We do the same thing here. We add 2k pi or 2n pi in both cases. Pi over 6 plus 2k pi, 11 pi over 6 plus 2k pi. So very straightforward, everybody. All right. Let's move on. We want to solve this equation, square root of 3 tan 3 theta plus 1 equals 0. And again, in one complete revolution from 0 to 2 pi. First, we're going to move the 1. Then we're going to divide both sides by square root of 3. So tan of 3 theta is negative 1 over square root of 3. And if you rationalize that, you get this one, because this is a common arc. You should know that. And if you want, you can even assume this is x. So if tan of x is negative square root of 3 over 3, what is x? And I'm going to explain how to find that. Now, first and foremost, assume, let me just write this here. I want to make sure that we understand what's going on here. If we had tan of x equals positive square root of 3 over 3, and we go with the reference arc, only the first quadrant would be pi over 6. Okay? This is a side note, everybody. When it's negative, you know tangent is negative in the second quadrant and the fourth quadrant. So tangent, so you should know tan x is negative in quadrant 2 and quadrant 4. Therefore, to get to quadrant 2, you put pi minus pi over 6. Quadrant 4, 2 pi minus pi over 6. Because this, everybody, is a reference arc. Okay, I want to make sure we understand exactly how we get to the answers. So again, if it were positive square root of 3 over 3, x equals pi over 6 would be the reference arc. You can figure out what happens with the negative. according to the fact that it's a tangent, the second and the fourth quadrant, so you have those answers. So that means x or 3 theta are those two numbers. Okay. Now, we are going to finish the job, but that's the first thing that I want to make sure that you get. Whenever you have multiple angles, 3 theta or 2 theta or 5 theta, in order to find every answer in the first revolution, 0 to 2 pi, here's the process. To each one, you add its period, of course. In this case, is pi, so n pi. In the case of, for example, sine and cosine, we would add 2n pi. So we're going to add n pi. Why do we do that? Because we want to find all the solutions from 0 to 2 pi, and we're going to divide both sides by what number? 3. So if I divide by 3, what happens? If I divide this by 3, that means I'm going to divide this one by 3. I'm going to divide this one by 3. Same thing here. I want to make sure everybody understands what happens. When you do that, the left side becomes theta. This one, when you divide a fraction by a whole number, just multiply it by the denominator. This is 5 pi over 18. This is n pi over 3. This is 11 pi over 18. This is n pi over 3. So you're right there. Now, I want you to know only for tangent and cotangent that we have n pi. We can write the top one, and n goes from 0 to 5. I'm going to explain that in a moment, 0 to 5, by looking at the other method. The other method, normally, in the case of sine and cosine, where we have 2n pi, we can't do this. This because the period is pi, it works. Instead, we use this, and we go from 0 to 2. This 3 theta, if you use 0, you get the answer. If you get 1, you get the answer. If you get 2, you get the answer. If you get to the next one, which is 3, brings you, it is a complete revolution, and more brings you back to 0. Okay. So the methodology is you go 0, 1. This number must be 1 less than that in general. Okay. But since it's a tangent and n pi is good enough, you can go all the way to 5. And again, if you use 6, by the way, on this one, brings you back to the same value as 0 plus a complete revolution. Okay, so let's plug in. Either way is fine. We can use this one and do this one and do 0 to 5, or we can do on this one 0, 1, 2, and then this one 0, 1. Either way makes no difference. Let's start with 0. When you plug in 0, everybody can see that if I replace the n with 0, one of the answers is 5 pi over 18. One of them is 11 pi over 18. I hope you see that n is 0. I want to show you what happens when n is 1. So if I choose n equals 1, I get 5 pi over 18 plus n, which is 1, times pi is just pi over 3. Remember, pi over 3 is 6 pi over 18. So you get 11 pi over 18. And if you plug in a 2, for example, you get 5 pi over 18 plus 2 pi over 3. Now 2 pi over 3, let's write it actually. 5 pi over 18 plus, if you change this to 18, you have to multiply the top by 6 also. 17 pi over 18. I do one more and you can finish it. So if I put 2 here, let me use a different color here, class. So if I put 2 here, I have 11 pi over 18 plus 2 pi over 3. Common factor of 18 gives me 12 pi at top, and I get 23 pi over 18, and I can let you finish the rest. So this may be a faster method, okay? In any event, each one gives you 3. There are a total of 6 answers. All right, let's look at this case. A cosine of theta minus pi over 4 equals 1. And again, we are interested in the interval of 0 to 2 pi. Now, assume this is x or y or z or alpha or beta or gamma. Think about this. If this is, let's say, cosine x equals 1, then x must be 0, because cosine of 0 is 1. Again, one of those common arcs. Cosine is equal to 1, x must be 0. That means theta minus pi over 4 must be 0. That means theta must be pi over 4. And there's only one answer. By the way, 2 pi gives you the same answer, but 2 pi and 0 are in essence the same. That's why over here, we don't have the equality. We don't want to repeat the same thing. Sine of 2 theta is 1/2. Again, imagine it's x or keep it as 2 theta. As you know, by now, we are comfortable with that. The reference arc is pi over 6. Assume this is, you can even assume it's just x. So x or 2 theta is pi over 6. So in the first quadrant, sine is positive. Also in the second quadrant, I've shown you that pi minus pi over 6. So that makes it 5 pi over 6. So you should know, it's elementary, you should know those are the 2 answers. Anytime you have multiple angle, you keep it, okay? And in order to find all the solutions, whether you want it in 0 to 2 pi or not, you have to add 2k pi and work on it. Now, when we add 2k pi or 2n pi, this is what happens. If they said find all solutions, you're done. There are infinitely many solutions. However, if they said, okay, just from 0 to 2 pi, if that was the case that you had to do, and we are going to work on that also, then you have to solve for theta, which means you are going to divide by 2. If we divide by 2, what happens? This becomes theta. Now, pi over 6 divided by 2, multiply the 6 and 2. So pi over 12, and of course, k pi. 5 pi over 12 and k pi. And now, since the multiplier is 2, you go with 0 and 1 only. So let k be 0 and 1 only. N minus 1, if we are dealing with sine of n theta, start from 0 and all the way to n minus 1. For example, n is 10, 0 to 9. So if you plug in 0, everybody, Now let's look at the top one. If you plug in 0, you get pi over 12 here, 5 pi over 12 here. Let's plug in 1 and I'll show you 1. So 0 is clearly, this goes away. So we have those two answers. Let's plug in 1, see what happens. So if I plug in 1, I get pi over 12 plus 1 times pi. As you know, I can say this is 12 pi over 12. That's the answer. And if I do the same thing here, I get 5 pi over 12 plus pi. Pi is 12 pi over 12. And that gives me 17 pi over 12. Those are the answers. And by the way, if whenever you come up with the answer, it's really a good practice if you have time to check one by plug in pi over 12. Okay, just for the sake of argument, that's the easy one. If you plug in 2 times that makes it pi over 6, and the answer is 1/2, and then do the rest of it. You really should check, and it doesn't take long. That's the best course of actions. Solve the trigonometric equations, quadratic in form. So 2 cosine squared theta minus cosine theta minus 1. If you have a difficulty factoring the way it is, you can let cosine be, for example, x, in which case you have 2x squared minus x minus 1 equal to 0. If you can do the factoring, you use the factoring. And it's very easy to use the factoring because 2 is a prime number, everybody. It's just 1 and 2. And negative 1, you have no choice but to go with 1 and 1. One of them negative. So I'm assuming you can factor this. The only thing you want to pay attention to, make sure the middle term, this is cosine theta. This is minus 2 cosine theta. And they do add up to the middle term of minus cosine theta. I hope everybody's okay with factoring, okay? And so now you're going to solve each. 2 cosine theta plus 1 equal to 0, or cosine theta minus 1 equal to 0. You move the 1, becomes negative, divide by 2. So cosine theta is negative 1/2. This one cosine theta equals 1. Now this one clearly just theta is 0. It's just one answer and there's nothing else you can do. You're done. Let's discuss this one. If it was 1/2, and let me write it because I want to make sure you come up with the proper answer easily. So if you look at cosine theta equals 1/2, theta equals pi over 3. This is theta r. Reference arc is pi over 3, everybody. Reference arc is pi over 3. We are looking at negative 1/2. Negative 1/2. Cosine is negative in quadrant 2 and quadrant 3. In quadrant 2, pi minus the reference arc. In quadrant 3, pi plus the reference arc. So if I add pi to that, I get 4 pi 3 here. If I subtract it from pi in the second quadrant, I get 2 pi over 3. This is how you get all of those. And now you write, this is theta equals 0, and you write all of them together. By the way, a lot of questions can be done by factoring. If you can't do the factoring, you have to use the quadratic formula. if we can't factor it, ax squared plus bx plus c equal to 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. We can use the quadratic formula to solve. Sine squared minus sine theta equals cosine squared theta. This is also a quadratic equation. How do we solve it? Because this is sine squared, this is sine. If we could change this into sine, it works out. And as you know, sine squared plus cosine squared is 1. Therefore, cosine squared is 1 minus sine squared. I'm assuming everybody can knows that, everybody knows that and can make the transition. So we bring everything to the same side. This one becomes positive, gets added to sine squared. We get 2 sine squared. And then minus sine theta minus 1. Again, to do the factoring, I want to just remind you, just the way it is class, you just write sine theta 2 sine theta because 2 is a prime number. And then negative 1, you have no choice but to go 1 and 1. So you can say plus 1 minus 1 or minus 1 plus 1 and see which one works. Okay. And how do we know which one works? Look at the middle term. This is positive sine theta. This is negative 2 sine theta. Do they add up when you add them up to the middle term negative sine theta? That's all there is to it. So this one sine theta is negative 1/2. This one sine theta equals 1. And of course, this we know there's only one answer, pi over 2. This one, again, quickly I'll show you, although by now you know that if we had positive 1/2, then the reference arc would be pi over 6. Reference arc. Because this is negative, sine is negative in quadrant 3 and quadrant 4. In quadrant 3, we are going to add pi to the reference arc. So pi and pi over 6 makes it 7 pi over 6. In quadrant 4, 2 pi minus the reference arc. 2 pi minus pi over 6 is 11 pi over 6. So that's how you arrive at the answer. Again, I went over the details of how you use this reference arc, everybody, okay? So I hope everybody is comfortable with that. But as I mentioned it before, I think by now you're comfortable with that and you don't have to just write all those steps. If it helps, by all means, okay? Of course, this is pi over 2 as well as it was mentioned. And so let's move on. And just for the sake of argument, if the question was not in this interval, but all solutions, then you would write this one plus 2n pi or 2k pi, this one plus 2n pi or 2k pi, the same thing, this one plus 2k pi or 2n pi. Okay, you just add that. All right. 3 sine squared equals cosine squared. I've already shown you that, reminded you that sine squared and cosine squared is 1. So just change one of them. It doesn't matter. Since this has 3, let's change this one to 1 minus sine squared. So if I bring this one to this side, becomes plus, and we have 4 sine squared equals 1. going to keep the 1 on the other side because it's easier to divide by 4. And then say, take a root, okay? Sine is plus minus the square root of 1/4, which is plus minus 1/2. So what we have, let's calculate both. We have sine theta equals positive 1/2. Sine theta equals negative 1/2. And this we have done, and we should know the answer is pi over 6. And sine is positive in the second quadrant, right? 5 pi over 6. Make sense, everybody? What about negative 1/2? Remember, for that now it's the reference arc. And sine is negative in the third and fourth quadrant. In the third quadrant, pi plus the reference arc. In the fourth quadrant, 2 pi minus the reference arc. Therefore, pi plus pi over 6 is 7 pi over 6. 2 pi minus pi over 6 is 11 pi over 6. And you get those 4 answers. Those 4 answers. It should be pretty clear, everybody. Any questions? All right, so again, because we have the negative 1, we get to have all of them. Okay, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, all of the above. So it's very straightforward, I hope. Okay, everybody. Now, 3 cosine theta plus 3 is equals 2 sine squared theta. On the left side, we see cosine, so we can change this to a cosine. So 2 times. We replace the sine squared by 1 minus cosine squared. So we get on the right side 2 minus 2 cosine squared theta. When we move this one to the right, we get positive 2 cosine squared theta. When we move this one to the left, my apologies, we get minus 2. And with the positive 3 becomes positive 1. So just bring everything to the same side. And again, this is a prime number class. So again, if we were to set it up, we would say cosine theta and then 2 cosine theta. And again, this is 1. So 1 and 1 or negative 1 and negative 1. Okay? Because this is positive, both must have the same sign. And this is positive, so they both must be positive. It's really simple to do the math here. I hope everybody is okay with that. Now, by now we recognize 2 cosine theta plus 1 is 0. That means cosine theta is negative 1/2. Cosine theta plus 1 is 0. That means cosine theta is negative 1. Again, this one very fast we get to pi because cosine theta is -1. And from 0 to 2 pi, there's only one answer. For this one, again, we've done the 1/2, which was pi over 3. Recall. Cosine theta equals 1/2. Reference arc is pi over 3. Okay. And so because it's negative, of course, the reference arc remains the same. Second quadrant, pi minus pi over 3 is 2 pi over 3. And the third one, pi plus pi over 3 makes it 4 pi over 3. We've done that before. You can go back to the notes. So there are two answers, 2 pi over 3 and 4 pi over 3. Over here, there's one answer. So we have a total of 3 answers if the question is asking for all solutions. Then you add 2n pi to this one, 2n pi to this one, 2n pi to this one, because sine and cosine have the period of 2 pi. All right. This is 3 cosine theta. So we're going to solve sine squared theta equals 3 cosine theta plus 1. So sine squared is 3 cosine theta plus 3. I'm using a lot of examples because if you go through the examples, I can't imagine you having any difficulty with your homework and, more importantly, your exam. So we want to bring everything to the same side. Because this is negative, let's move everything to the right. So this becomes positive cosine squared plus 3 cosine theta 1 becomes -1, and 3 is +2. And this is easy. You just write cosine and cosine, okay? You want two numbers. The product is 2. The sum is 3, so therefore 1 and 2. So that's a very simple factoring, everybody. Cosine theta is either -1 or -2. -1, as you know, there's only one answer, pi. Cosine theta equals -2. I hope you know that it has no solutions. So the way we write it, we say this one has no solutions. This is phi, which represents an empty set. Because cosine is between -1 and 1, there is no solution here. So this equation has only one solution from 0 to 2 pi, namely pi. Cotangent squared theta is 3/2 cosecant theta. Well, we are going to use one of those Pythagorean identities. 1 plus cotangent squared is cosecant squared, or cotangent squared plus 1 is cosecant squared, either way. So we're going to replace this one with cosecant squared minus 1. So we're going to move this, make it -1. First, we move everything to the same side, and then we multiply by 2. If I multiply by 2, I get 2 cosecant squared theta minus 2 equals 3 cosecant theta. And now I'm going to move everything to the left. So 2 cosecant squared theta minus 3 cosecant theta minus 2. And again, factoring. There's a lot of factoring involved, and 2 again is a prime number, so 1 and 2. So 2 cosecant theta, and then just work on -2, write it as a product of only two numbers, 1 and -2, or -1 and +2, and work it out. So I'm going to leave it for you. By now, you should know this is cosecant theta. This is -4 cosecant theta. They do add up to -3 cosecant theta. The middle term, because my assumption is, you know, you want 2 here, You know you want -2 here. It's easy to get those. Even if you have -1 and +2, you still get that one. That's why you check the middle term, class. You multiply these two, you multiply these two, you add them up, and you check with this one. Therefore, cosecant theta is -1/2 here and +2 here. Well, we have memorized sine, cosine, tangent. Perhaps we don't remember cosecant. So let's go with sine. Sine of theta is the reciprocal of this, which is -2. And in this case is +1/2. This has no solution, just like cosine, because sine is between -1 and 1. This doesn't give us any solution. This gives us two answers, pi/6, and then in the second quadrant, sine is +5 pi/6. Again, we've done this before. You can go back to the notes. Again, this one, everybody, this one gives us phi. Phi means an empty set in set theory, everybody. All right, let's switch gears and take a look at slightly different types of questions that require perhaps calculators. So let's solve cosine theta equals 0.2 from 0 to 2 pi with 2 decimals. Well, this is not a common arc. I don't know the answer. I have to use a calculator, so I'm going to write theta is cosine inverse of 0.2. Now, bear in mind, we're going to come up with the answer, but when you go with the inverse function, it gives you one answer. And remember, we want it from 0 to 2 pi. So there are two answers. We have to use then our knowledge of 0 to 2 pi, and in this case, cosine, to figure out other answers, okay? So first and foremost, if you plug it into a calculator and write cosine inverse of 0.2 gives you this number. Since we want two decimals, look at the second decimal, is 6. Next to it is 9. So here's the second decimal. Next to it is 9. We take it up one notch. We make it 1.37 radians. Is this the correct answer? Yes. Is this finished? Absolutely not. Why not? Because cosine is positive in the first quadrant and the fourth quadrant. And this is the correct answer. It is also your reference arc. So basically 2 pi minus that is the second answer. So for inverse cosine, the calculator will only give you an angle from 0 to pi. Why 0 to pi? Because remember, we restricted the cosine from 0 to pi. There's another angle in the interval of 0 to 2 pi with that cosine value in quadrant 4 because it's positive quadrant 4. 2 pi minus that. So this is the first one in the first quadrant, 1.37 radians. By the way, as you know, this is pi over 2. This is pi, and pi over 2 is 3.14 over 2 roughly, which is 1.57. So the first quadrant. And then here's the third quadrant. So subtract this much from 2 pi. So this is theta equals 1.37. And this is theta, this red angle is 2 pi minus 1.37. And now you use a calculator and two decimals, and it gives you 1.37. And this one gives you 4.91. So if it's not a common arc and you're using your calculator, you should be able to figure out the second one in this manner. What about a negative value? Tan theta is equal to -2. And so it's not a common arc. I don't know the answer. I need a calculator. So I'm going to write theta is equal to tan inverse of -2. And tan inverse of -2, if I put it into a calculator, gives me a negative value. And there's nothing wrong with that. It's a perfect answer. But that's the reason we want to be careful, because we don't want a negative answer. We want a positive answer from 0 to 2 pi. That's what they're asking us. So you want to pay attention to why we are going to make some changes now. First of all, there are two answers. Secondly, we want both of them to be positive. Okay? So this is the answer according to that. And we are going to go with 2 decimals. So we want the second one. We will look at 7 and change it to 1. That's why it's an approximation, everybody. This is an approximation, okay? All right. For inverse tangent, the calculator will only give you an angle between negative power 2 and power 2. There is another angle in the interval from 0 to 2 pi with that tangent value in quadrant 2. Remember, tangent is positive in the first and third quadrant, and it's negative in the second and the fourth quadrant. Negative in the second and fourth quadrant. What do we do? Pi, if we add pi to that, it gives us 2.03, and that's in the second quadrant. Why pi? Remember the period for tangent and cotangent happen to be pi. And if you add 2 pi to this number, that gives you the second one in the fourth quadrant. So take a look. This is what the calculator, the inverse tangent function gave us, which is a negative angle. There is nothing wrong with that. However, the question is asking us from 0 to 2 pi. So all you have to do, add a pi, you get one of it in the second quadrant. And if you add 2 pi, you get the second one in the fourth quadrant. So 2.03, 5.7. So in short, whenever you have a negative tangent, okay, add pi and 2 pi, and it puts you in the interval of interest 0 to 2 pi. So whatever the answer you got here, add pi and 2 pi. Why? Because this was a negative tangent. Solve and round to 2 decimals again. 3 cosine x plus equals 4. This cannot be solved by algebraic method or the graphing utility as before. In fact, the methodology is to set this equal to one function like y1 and this one to y2. So we use a calculator. Y1 is the left side, Y2 is the right side, everybody. We graph them, and now we use the intersection to find the solution. So this is the graph of the left side, and this is the horizontal line y equals 4. The point of intersection we're looking for is this one. So use intersect to find solutions. And I'm explaining how to find intersect using a graphing calculator such as TI. Press calculator, which is second trace, choose intersect, which is number 5, and so on and so forth. So take a look. You go calculate. Number 5 is the intersect. You click on that. Okay. For the first curve, just hit enter. For the second curve, hit enter again. And then for the guess arrow to the intersection, close to that, and hit enter. And it reads the answer. Take a look at the number here. It gives you the answer, but We want two decimals. This one next to it is 3 and it doesn't change. 4.53 is the answer. So very straightforward, everybody. Solve 2 sine squared minus 3 sine theta plus 1 equal to 0. Again, something that we've seen since this is a prime number is just 1 and 2. And since this is 1, both of them are positive 1 or negative 1. This makes it negative. So it's a very simple factoring. Either 2 sine theta minus 1 is 0 or sine theta minus 1 is 0. This results in sine theta being 1/2. And this sine theta being 1. Both of them we have already solved. This obviously has one simple answer, pi over 2. This one has the answer pi over 6. In the first quadrant, remember sine is positive in the second quadrant, so pi minus pi over 6, also 5 pi over 6. And as I mentioned here, in this case is pi over 2.